All right, so here we go with the review for the quiz tomorrow. I printed myself out some bell curves here so I can start talking about them. Use the 68, 95, 99.7 rule to calculate some probability. So, I need to calculate some probability that a number is less than 3 standard deviations below the mean. So I'm going to start labeling one here. This would be my mean. This would be 1 standard deviation above, 2 standard deviations above, and 3 standard deviations above. And then if I go to the other side, -1 means that's 1 standard deviation below. -2 means that's 2 standard deviations below. And -3 means that's 3 standard deviations below. Now, the 68, 95, 99.7 rule, if you remember, this right here between 1 below and 1 above, oh, that's really awkward there, represents 68%. If I cut that in half, that makes this 34%, 34%. Then if this is worth 95%, these 4 sections, 1, 2, 3, 4, and I've already used 68% for those two, then let's see. 95 minus 68 leaves me, oops, sorry, wrong one. 95 minus 68 leaves me 27% to be split evenly for those two. So if I divide it by 2, that means each of those is 13.5%. 13.5%. And then 99.7% is in here, but this makes up 95%. So let's see, 99.7 minus 95% means I have 4.7% left for these two segments right there. So I'm going to cut it in half. That gives me 2.35%. 2.35%. And 99.7%, so 100 minus 99.7, means I have 0.3% left for these two teeny little outside parts. Dividing that in half gives me 0.15%. So this guy right here is 0.15%, and this guy right here is 0.15%. Now you're going to have to come up with that on your own come the quiz time. So the probability that a number is less than, that means to the left of, 3 standard deviations below the mean. Well, here's 3 standard deviations below. If I add up everything to the left, there's only this one section. So that gives me what? It gives me 0.15% is my percentage there. By the way, this could be written like this. That means the probability that z, remember these are also z-scores, this is approximately a z-score of 1, of 2, of 3, of -1, -2, -3, that your z-score is less than -3, meaning to the left of -3. That's another way that this question could be asked. But this one we get is 0.15%, meaning on the left of the -3. Okay? What is the probability that a number is greater than, so that means I'm going to be looking to the right, of 2 standard deviations above the mean. So that would be a z-score of 2. If that was written in this z-score notation, it would say what is the probability that z is greater than 2. If this is 2 standard deviations above the mean, I have to add up 2.35 plus 0.15. So 2.35 plus 0.15 is equal to 2.5%. That's my probability right there. Okay? And then the probability that a number is between 1 and 3 standard deviations below the mean. In other words, what is the probability that z is between -3 and -1? Well, if this is -3 and this is -1, what two numbers am I adding together? 2.35 plus 13.5. So 2.35 plus 13.5 gives me, plus 13.5, gives me 15.85%. Okay, so all of those are using the 68, 95, 99.7 rule. I don't have to have any z-scores, even though Z could be listed there, it's going to remain these nice values of Z that I can use that rule for. Okay? All right, moving on to the next problem. I think all of these have to deal with this circumstance. Birth weights in a population are normally distributed with a mean of 109 and a standard deviation of 13. Okay, and then it says Sarah was 122 ounces when she was born. So I'm going to do this. I'm going to take my bell curve. My mean is 109, and my standard deviation is 13. So let's see. 109 plus 13, that gives me one standard deviation above. That gives me 122. Add another 13 or another standard deviation, and I have 135. And another standard deviation, 148. And these are all ounces along this bottom row. Now to find these guys, I go back to my 109, and this time I'm not going to add 13. I'm going to subtract 13. So this would be 96 ounces. Subtract another 13, that gives me 83, and then finally subtracting another 13, that gives me 70. So that's where I'm at. If I keep the percentages from above, I have 34, 34, I'm just copying these from above, 13.5, 13.5, 2.35, 2.35, and 0.15%. 0.15%. So now I should be set up to answer any questions that I'm asked about this. So first thing it says is convert Sarah's weight to a z-score. Now I don't actually need my bell curve for that. So 122 is her weight, so I take her weight. I subtract the mean, which is 109, and then I divide it by 13, the standard deviation. So, as I do this one, 122 minus 109 gives me 13. Divided by 13 is 1. So I have a standard deviation of 1, which should match up if my standard deviation is 1, not my standard deviation, if my z-score is 1, then I should be 1 standard deviation over the mean, which 122 is in that 1 standard deviation above the mean point. So what is her weight as a z-score? Well, the z-score representing her weight is 1. The next question says, what percent of all birth weights would you expect to be lighter than 122? Well, if this is 122, right here, all of the weights to the left of there are lighter than 122. A 70-ounce baby is lighter than a 122. So I'm looking at the ones, to the left. The ones to the right would be heavier. So let's see, if I added 0.15 plus 2.35 plus 13.5 plus 34 plus 34, that gets me to this 122, and it gets me my answer. Now, if I know a little bit more, I don't need to add those all individually, because how much is this from the left side to the mean is going to be 50%. So if I take that 50% and I add this extra 34% to get me up here, that leaves me with 84% is what we would expect to be lighter than 122 ounces. What percent of all birth weights would you expect to be heavier? Well, that would be to the right side. Heavier would be to the right side. So, there are 3 different ways that I could look at this. First off, I could recognize that to the right of there is this entire 50% half minus the 34% that's not a part of it. So I could look at 50% minus 34%, and that gives me 16%. 50% minus 34% equals 16%. That's one way I could look at it. Another way I could look at it is I could add 13.5 plus 2.35, not 23135, plus 0.15. That also gets me my 16%. The other way I could look at it is since I know that the left half, or below 122, is 68%, not 68%, it's 84%, I could take 100% and subtract that 84%, and that also gets me the 16% that's right there. So any of those ways that you choose to do that, you get 16% as your result. The last question, if we consider usual weights to be those with z-scores between -2 and +2, was Sarah's birth weight usual or unusual? Well, I can't tell that from these percentages necessarily because they give me z-scores to compare. If her z-score was 1, does that fit? They're telling me that normal is between -2 and 2. Well, 1 happens to fall right in there. Look at that. My 2 looks like a Z. 1 happens to fall in that range, doesn't it? So that makes her weight usual. So you have a question similar to this on your quiz. I want to see that word, either usual or unusual. And then you would say something to the effect of 1 happens to fit in that range of -2 to +2. Or you could say something, you could even write it in a sentence form. You could say 1 is between -2 and 2. You could write it as a sentence also. Okay, but make sure you give me that word first. Okay? All right, moving on. Now I have it on a separate page just because I wanted a little more room to write stuff out. But it says, sorry, I had to grab a table. Use a standard normal z-table to calculate the following probabilities. Now, this one you have to be careful of the symbol. This one says less than. This one says greater than. This is between. If it says less than, then I'm looking for exactly the number I get off the table. If it says greater than, then whatever percentage I get, I have to subtract from 100% in order to get the right-hand side. So I'm actually going to highlight some things just so that you can see where I'm looking at with these. So using a standard normal table, z is less than positive 1.21. So less than means I'm using the exact percentage I get off the table. So now I have to find 1.21. Here's 1.2. And this would be 1.20. And this would be 1.21. So I find where those meet up. And I get 88.69%. You could either write 0.8869, or my preference is actually 88.69%. Okay, that's my result right there. Z is greater than 1.21. Well, that's the value. 1.21 is what I just looked up. But if I want greater than, I have to do 100% minus what I just got, minus the 88.69%. And if I subtract those, 100 minus 88.69 gives me 11.31%. Okay. Okay, when it says between, I have two things to look at. So -2 is the first one, so I'm going to have to flip over to my negative side. And -2 would be -2.00. That would be -2.0 and the 0.00. That's right there. That gives me 0.0228, or in other words, 2.28%. And 0.38 is my other number that I'm looking up on my z-score chart. That's positive, so I'm going to flip over there. I'm looking for 0.3, which is right there. And if we go all the way over to the 0.8 and see where those two match up, I have 0.6480, which is 64.80%. So what do I have to do? I have to take these, and I take the bigger percent, and I have to subtract the smaller percent. That will give me the amount between. So 64.80 minus 2.28 means that between there I have 62.52%. Okay. All right, let's go to the next line. Z is greater than, meaning I'm going to have to do 100% minus whatever I get. So negative 2.58. So I'm going to start off with negative 2.5, which is right there. And then my 0.8, negative 2.58, hang on, is 0.0049, which is 0.49%, which is a lot. Or I'm sorry, it's very, very tiny. So when I subtract it from 100%, that's going to be a big number. So 100% minus 0.49, 99.51%. Why is that so big? Well, if I'm looking at here, and I'm wondering, actually it's probably easier to look up here. This is almost 3 standard deviations. It's 2.5 standard deviations. So I'm looking at only a small amount to the left of there, so it is going to reflect the majority of the population there, of the bell curve. All right, so last one here. Well, actually I've got the betweeners, but this one's less than, so I can just take the value that's off the chart. Negative 3.20. I have 0.0007. That would be 0.07%. Again, you move that decimal 2 places to turn it into a percent. Okay. What about the probability that z is between 3.1 and 1.28? So let's find 3.1. That'd be on my positive side. 3.10. 3.10 is 9990. Well, 0.9990. That's 99.9%. And 1.28, here's 1.2. Let's go all the way over to the 8 column. I get 89.97%. 89.97%. And if I subtract those, 99.9% minus 89.97%, I get 99.9 minus 89.97 is 9.93% for between. Again, between, you find both of them, and then you subtract them. All right, now this last section is actually pretty easy. I'm not asking you to calculate anything. I just want to make sure that you understand the language, okay? So if they're saying something that is at least 5, does that mean that z is greater than 5? Or z is less than 5? Z, or you could use x. We'll use x since that's what the example says. So does that mean x is less than 5 or x is greater than 5? Well, if x is at least 5, that means that the smallest number is 5. It could be 5, 6, 7, 8, and counting up from there. So what expression, x is greater than 5, would that be those numbers, or x is less than 5? It's not going to be that guy. It's going to be x is greater than 5. Okay? At least people tend to want to put a less than sign. It's actually a greater than sign because at least means you're talking about all the numbers bigger than that. Okay? The next one says at most 5. Well, at most 5, that means 5 and all the numbers that come before it, and so on and so forth. So these all would be values that are less than 5. For our purposes, it doesn't really matter if you use less than or equal to, or greater than or equal to. I think Ms. Armstrong kind of noted that down there. It doesn't really matter whether we use these symbols or these symbols, but it does matter that you're going the correct direction with what you're doing. Okay? Taller than 5, hopefully that makes sense that it's greater than 5. Shorter than 5 would be less than 5. Lighter than 5, if we're talking about weight, that would be less than 5. Over 5, like maybe over 5 years old, that would be greater than 5. So the two that people most often get confused would be 14 and 15, making sure that at least you're actually using the greater than sign and at most you're actually using the less than sign. Okay? All right, 25-point quiz tomorrow. Happy studying.